Hi guys, welcome you all to my channel Explore Edu to Teach.
With another video of random signal analysis in standard distributions. We'll be talking about discrete distribution and we'll be talking about continuous distributions. So in discrete distribution we have the uniform, binomial, Bernoulli and the Poisson, and the continuous distribution we'll have the uniform, exponential and the normal distribution. So we'll be talking about each and every distribution in detail and trying to understand it. For the entire notes, please join my Telegram group. The links are given down in the description box. All these formulas which are there in these distributions will be uploaded on my Instagram page also in the form of short notes. Please check out the links of my Instagram page, and if you like it, do follow me on Instagram also. The links are given down in the description box. So in today's class, we'll be talking about discrete standard distribution from uniform, binomial, Bernoulli. Then we have Poisson, uniform, exponential and normal in continuous. So we'll be talking about each kind of distribution in detail. What are these distributions? And then we'll be going ahead accordingly. Okay, so let's try to understand what are the different kind of standard distribution. There are two kinds of standard distribution. One is the discrete, other one is the continuous. So in discrete, we have the uniform, the binomial and the Bernoulli and the Poisson. So what is uniform discrete standard distribution? So in uniform discrete standard distribution, there is a random variable x, and this random variable x takes value from 1, 2, 3 till n, and the probability of each variable is given as 1 by n. So it's 1 by n, 1 by n, 1 by n and 1 by n. So you have the values of x from 1 to n, and each value of x will be taking a uniform distribution probability, that is 1 by n. So x is equal to 1, the probability is 1 by n, x is equal to 2, probability is 1 by n, x is equal to 3, probability is 1 by n, similarly x is equal to n, probability is 1 by n. This is the uniform discrete distribution. When I talk about binomial distribution, there is a random variable x, and this random variable x follows the binomial distribution as nck, p raised to k and q raised to n minus k. I repeat myself, a random variable x is said to be binomial distribution if the PMF, that is the probability mass function, I have taught all these concepts in the earlier class. Please go and check out my random signal analysis playlist. So if the PMF is equal to nck, p raised to k and q raised to n minus k, then that particular distribution is said to be as binomial distribution, in which p plus q is equal to 1. Then you have the expectation of binomial distribution is given as np, and the variance is given as npq. Now in case of Bernoulli, what happens is that you have n value as 1. So the expectation here is p and the variance is given as pq. I hope I am very clear with this. So basically there are different kind of distributions. One of the distribution, discrete random variable distribution, is the uniform distribution, in which the value of x goes from 1 to n, and the probability of each variable is 1 by n, 1 by n, 1 by n. Hence it is uniform discrete distribution. Then there is binomial distribution. The binomial distribution, basically you have a random variable x, and it follows the binomial distribution with the PMFs given as nck, p raised to k and q raised to n minus k, where p plus q is equal to 1, the expectation is equal to np and the variance is equal to npq. And when I consider this n, which is the number of times a particular action is taken place, when that is equal to 1, the binomial distribution becomes equal to the Bernoulli distribution. So let's try to take up a numerical and try to solve this numerical. The numerical says if x is a binomial distribution, that means if x follows this equation, expectation of x is 2, variance of x is 4 by 3, find the probability distribution. Okay, so what happens is that, let's try to understand expectation of x. Expectation of x is equal to 2 is equal to np. Variance of x is given as 4 by 3, which is equal to npq, which is equal to n into p into 1 minus p. Right? So basically you have to understand that the expectation value given is 2, which is equal to np from this formula. The variance value is equal to 4 by 3, which is equal to npq, that is np into 1 minus p, because as I told you, p plus q is equal to 1, that means q is equal to 1 minus p. So just take the numerator and denominator. 2 upon 4 by 3 is equal to np upon np into 1 minus p. And finally you get the value of p as 1 by 3, q as 2 by 3. And when you put these values of p and q in expectation, okay, the expectation is equal to 2, right? The expectation is 2. The n value is not known and the p value is given over here. So in that case, n is equal to 6. So once you have all the values of p, q and n, you know that n is equal to 6. So you start from 0 to 5. It's not 6. The total number of times is 6, right? N is equal to 6. So it will start from x is equal to 0 to x is equal to 5. 0, 1, 2, 3, 4, 5 is equal to 6 times. So start from NCX, p raised to x, q raised to n minus x. So n is equal to 6. 0 is here, p raised to 0 and q raised to n minus x. So n is 6, x is equal to 0, and try to find out all the values. Because 60, 0 you know, p raised to 0 is 1 and q raised to 6, the value is given to you, that's it. So I hope I am very clear about this. What is expectation of x? What is variance of x? And what is the probability distribution of this thing? So once you know what is expectation of x, what is variance of x, I think you will get all the values and finally you will get this value. So I hope I am very clear with this. So if you like this video, do not forget to like, share, subscribe to my YouTube channel. Follow me on Instagram for all the related updates and for all this formula sheets which are going to be uploaded on my Instagram page, and this entire notes will be uploaded also on my Telegram page. The links are given down in the description box. Thank you so much. God bless.